My name is Grayson. I just recently started my YouTube channel to have like debates like this and other topics based theory. So just today, actually, I'm pretty proud to say that just hit over 100 subscribers. So I'm pretty grateful for everyone that subscribed so far. So yeah, hopefully I want to do more after shows, more debates, and more content like this. So first of all, Jamie, Donnie already know that I disagree with this whole model of the 6 stages of evolution, right? Macro and microevolution are just the theory of evolution, right? And those other so-called cosmic, chemical, stellar evolution, those are all described by different theories of science. It's not that these are different stages for the theory of evolution umbrella. The theory of evolution just describes the origin of species and biodiversity. It doesn't explain where life came from, doesn't explain how stars formed, doesn't explain how the universe came to be. We're going to be talking about all those things. But my stance, I just wanted to articulate at the beginning because Jamie and I have already gone back and forth on this quite a lot. And I feel pretty confident in saying that no matter what I say, no matter what dictionary definitions I show him, he's never going to change. He's going to continue to say that these are all just parts of the singular theory of evolution. And he will not accept that the theory of evolution is just for biodiversity and species. So it is what it is. What we're actually going to be talking about is multiple different theories and hypotheses. The Big Bang Theory, stellar evolution, which is just the name of the theory. It doesn't have anything to do with biological evolution. And then we're going to talk about nucleosynthesis, abiogenesis, the solar nebular hypothesis, so all kinds of different topics. But I just wanted to, at the start, say that only stages 5 and 6 on his little roadmap there is actually the theory of evolution. So we're going to be talking about all the other stages, but that's just kind of the format we're going to be holding for the sake of the conversation tonight. So I just wanted to preface it a bit about saying these are a lot of different scientific theories that we're going to be discussing tonight.
Now, the best way to explain this for those that don't know that much about physics is imagine this grenade right here. We pull the pin and then it blows up, right? Well, when it blows up, we have a way to study and observe and verify that there's going to be certain directions that the pieces fly and they're going to rotate in a specific way. This is a simple diagram that kind of explains it. I know Kent likes to use the seesaw metaphor to explain it. But neither here nor there, scientists have observed this, studied it, tested it, and demonstrated it. So the conservation of angular momentum describes that everything will rotate a specific way based on the explosion. Here's the details of that. Well, actually, this is something that is relating to evolution specifically, so I'll just go ahead and read it. The angular momentum would have caused the sun to spin very rapidly, but actually our sun spins very slowly, while the planets move very rapidly around the sun. In fact, although the sun has 99% of the mass of the solar system, it has only 2% of the angular momentum. This pattern is directly opposite to the pattern predicted. This is actually coming from The Origin of the Solar System, which was written by Dr. H. Reeves. So again, I don't believe that he's a creationist, so I would have to actually go back and look at that to verify. But I think the last time I checked, this is not a creationist that's making this statement. So again, we see a problem with the sun as far as conservation of angular momentum is concerned.
Can I comment on what you've said so far and this quote in particular? Because I do know Dr. Reeves, and you're right, he's not a creation scientist. But I think that you're taking this quote a little bit out of context because the quote has nothing to do with the Big Bang, right? I mean, this is about the formation of the solar system. And this pattern is directly contrary to the pattern predicted. You kind of are having to fill in by the Big Bang there. And he's not talking about the Big Bang at all. He's talking about the accretion disk theory and the nebular model. And this was also back in 1978. We've had quite a few advances in our understanding since the late 70s. I mean, that was before either of us were born. Just in, I think, 2009 or 2013 or 14, we just had an increase in our understanding about angular momentum in planetary formation. So I don't know what this has to do with the Big Bang is my only object. I think that you might be kind of quote mining this a little bit to kind of take it
Okay,
out of its original
so
context.
yeah, so I'm not adding the Big Bang to this. What I'm saying here is that they have taken observable science, which is the conservation of angular momentum, and when people apply that to the solar system because you claim there's a Big Bang, it doesn't match up. Okay, the Big Bang would have certain physical characteristics to it. He doesn't directly say he's talking about the Big Bang. I didn't add it in there with any quotes, but this is his observation of the sun. He's saying this doesn't make sense according to the way that the solar system is and the way that we see observable science on Earth. Now, I know you like to make the argument that things work differently in space than they do on Earth, but that is not something that you can do and call science. When we were having our chats before the month before, you said something about space doesn't expand the same in as it would on Earth, so that's why conservation of
if I
angular
can
momentum doesn't count.
clarify, because it also addresses what you were talking about with the grenade analogy, and so I just want to point out the difference between an explosion and the Big Bang. So if imagine like kind of like two cubes for this analogy, right? Like 10-foot by 10-foot cubes. In one, you have a grenade, and the grenade explodes inside the cube. You have an expansion of the volume of the explosion from the grenade. You have like conservation of angular momentum at play because, like you said, the shrapnel all has to be conserving angular momentum. But the size of the cube doesn't change at all. Now, in our second cube, imagine that you are doubling the size of this cube. So it's no longer 10 foot by 10 foot. Now it's 20 foot by 20 foot. And all of the distance relationships between everything in the cube is doubled. So two things that were 5 feet apart are now 10 feet apart. So these are two very, very different scenarios. One is an explosion, the grenade, that's described by classical Newtonian physics. And the other is a expansion. There's no explosion in that cube. You've just expanded all of the distance measurements within that cube. That is what the Big Bang is. It's an expansion of space and time.
So it's funny that you say that because it wasn't until the last 2 decades, if I'm not mistaken, that they changed the term from explosion to expansion. So for a very long time, they taught explosion, and then they realized, oh, if we call it an explosion, then it has to match these laws of physics that we can't explain. And so they changed it to expansion. And even with that, a rapid expansion is still an explosion. I mean, that's just, there's no difference in it. Now, if space is expanding, but something is exploding, it should still have the same characteristics. Why would the laws of physics change in an expanding universe, as you want to call it, as opposed to what we observe today? And then the second question I have in regards to that is, if you want to say that it's different, well, the question is, how is that science? You can't observe that. Do you have a time machine to go back and watch the universe expand? Because if physics are different in the original expansion of the universe, right? But if physics are if the physics of a galactic expansion or whatever you want to call it, if that's different than what we observe today, then how do you know it? Like, how do you know that that's different?
I'll just clarify. It's not. I'm not saying physics works any differently back then than it does now. We still currently are observing the space-time of the universe continue to expand at faster rates, like right now today. And then you said that there's no difference between the explosion and the expansion, but that's what I was trying to explain with the two cubes. You understand the difference between the two cubes. One cube stayed the same size, and the explosion happened within the cube. So the volume of the explosion increased. But in the second example, the actual volume of the cube itself increased. So you see that there is a clear difference between those two concepts, right?
I don't see a difference between that because neither here nor there, it's still going to have the same characteristics as an explosion. Because this is the thing. A rapid expansion is what the new age textbooks call it, a rapid expansion. Well, if something is expanding at billions of miles of speed, that is an explosion. Now you're taking it into a different playground. Basically, you're taking it out of our Earth that we can observe and putting it into a space, the universe, that we can observe. And you're saying, oh, well, because it's in space, it acts differently. It's a cube expanding. But the thing is, How is that science? How can you prove that? That's what I want. I want you to prove, like, show me where they actually observed this. How did they replicate this? Because part of science is that you have to observe it, and you're not observing it, you're hypothesizing it, or you're assuming, in other words. Observe, study. You can't study it unless you go back in time. You can't test it unless you were to. I mean, is that what they're doing over there at CERN? Are they creating big bangs and, observing how the Big Bang acts? But even then, the Big Bang would be happening within our Earth gravity system. So the Big Bang wouldn't be replicatable to the universe. So that's what I'm saying. You're not following the steps of scientific theory or scientific method to prove this. This is religion.
So the difference is that in a traditional classic explosion, space and time are not changing volume. Okay, the explosion is changing volume. In the Big Bang and the expansion of space and time, right? Space and time itself are what are expanding in volume. So their space and time are not bound by the speed of light or properties of matter, right? Space and time are a metric, like a terms of distance measurement and time measurement. These things can expand like independently of the matter that is within them, right? The space and time is expanding between all the atoms of my body right now. Like it's just the molecular bonds keep the atoms together. And gravity does the same thing within our galaxy. But outside of that, right, we observe. This is called Hubble's law. The more distance that is between us and a star, right, the more redshift we're going to see, the more distance like has expanded. So the amount of space between us and a distant object predicts how quickly it's expanding away from us. And that would only be the case if it's the actual space and time that is expanding. And we know it's space and time because we can also look at distant objects in telescopes, and we can see that the actual time is slowed down. Like we are watching things in a slower motion than they are normally occurring because the actual space and time has expanded between us. So Hubble's law, like the relation between the distance and the amount of space and time dilation that we observe, is observational evidence of the expansion of space and time right now, like continuing to happen today.
So I haven't heard too much about Hubble's law, so I'll look into that. But from the way you explained it, it seemed like there's a lot of assumptions that go into that. Because what are you observing? You're observing a star, right? You're observing the stars themselves, right? And when you observe a star, all you're observing is the light from that burning star. So you're making a lot of assumptions based on a burning star. That's all you see is a star's burning. So you can't look at a star and say that star is burning and it's burning slower or faster, or we see a red shift. Therefore, the Earth, the universe is expanding. Like that's a hard thing to prove with that's a hard thing to prove off of what you're observing. So again, a lot of built-in assumptions go into that, and that's why creationists always make the claim that yours is just as much a religion as ours, because you have to put a lot of faith and a lot of assumptions into it. Now, with creationists, specifically Christian creationists, we're not assuming anything. The Bible tells us what we need to, what our format is, essentially, and we're just over here taking the verses and trying to back them with science. You guys are taking nothing as a foundation and just making it up as you go. That's why the definitions change every 2 years. That's why the theories change. That's why at one point in time, punctuated equilibrium was the main theory. And then they realized, oh, that fails. Let's scrap that. Time and time again, we see that humans are wrong in their interpretations, and they have to constantly rewrite it. But when you look back at the debate of creation versus evolutionism, creationists have never had to change their model. In fact, the more science advances, the more it answers our model. For example, mitochondrial Eve is a good example. You guys, evolutionists, were the ones that came up with mitochondrial Eve, and they made the name because they were mocking Christians. But then when we actually got more into the science of it, and Donnie and Matt do a great job of this, when they actually studied the mitochondrial Eve from a creationist perspective, it did prove Eve. And so then evolutionists had to try and backtrack themselves and change the name, and I don't know what they try and call it now, but they have tried to rename it since then, and it hasn't been able to change because it's already stuck. So again, creationists never have to change their model. Evolution always is changing its model because it's always being proved wrong. And if we get to micro evolution in 4 hours, then I'll show you more examples of that. So,
Okay,
yeah.
in the spirit of what you're saying, like we want to get to the later topics. I don't think mitochondrial Eve is very on topic, and Donnie and I have had discussions on it. So if anyone's curious, they can look at that. But I kind of want to get back to the Big Bang. I don't really see it as being part of like the discussion for tonight. As far as I'm concerned, it's still called mitochondrial Eve. I don't think mitochondrial Eve is evidence to support creation. I think it's just predicted by math and population genetics. But we can move on.
Okay. All right. I just wanted to make sure you got to respond to everything I said before I went back to the presentation. So my buttons don't really work the way I want them to on my hotkeys. So I have to like constantly go back and forth between the screens manually. But yeah, so conservation of angular momentum. This is from Cambridge. The ultimate origin of the solar system's angular momentum remains obscure. That's from Cambridge University. So again, they just can't explain it. That's from 1992. So I understand 20 years ago, whatever. So I know you're going to discredit that based on age.
30 years ago, your age is showing, Jamie.
Oh, yeah, 30. Yeah, man, I wish I was still 10 years back. But yeah, so yeah, you're right. 30 years, my bad. Okay, so here's one of the things about the conservation of angular momentum that I'd like you to answer. Venus and Uranus rotate backwards from the other 6 planets in our solar system. We have some theories about how the spin of Venus may have been pulled into the sync with the Earth. Unfortunately, they don't really work. This is coming from David Grispoon, assistant professor, astrophysical and planetary sciences. And this comes directly from his book, again, 97, so almost 30 years. But these are the kind of things that I want answers to because it doesn't make sense according to the model. Now, even if the universe is expanding, it should still fit within our laws of physics. So if the universe is expanding at the same time that all of these, all the matter in the universe is creating everything, well, why is there some things that are rotating a different way than other things? Shouldn't they all be following kind of the same format? And then, I know we talked about cosmic microwave background radiation, but I don't have that in the presentation. But again, why doesn't that show the same pattern? We see the planets rotating in different directions. It doesn't make sense. Not just the planets, but also the moons. And this one right here is kind of the example that I really like to take. 8 out of 91 moons rotate backwards. Jupiter, Saturn, and Neptune have moons that orbit in both directions. So why is it that these 3 planets have multiple moons that are rotating in different directions within the same orbit? It's because the argument that I hear for Uranus and Earth and Venus is that, because they're in different orbits. Well, how do you explain that with the moons? Okay, because the moons, let's say that I don't know exactly how many moons Jupiter has, but let's just assume 2 because there's obviously more than one, and they're orbiting in different directions. How do you explain that when they're in the same orbit? I think that's a good spot to pause.
Yeah, I'd like to respond to some of those points. So the first thing I want to say is that the Big Bang does not, the expansion of space and time does not inherently impart angular momentum on anything in the universe. Going back to our example with the 2 cubes, right? When you have a grenade go off in the first cube, all of the shrapnel has to obey the laws of conservation of angular momentum because the explosion is a classical process. The expansion of space and time, right? The second cube, when you've just simply doubled all of it's like a metric increase in scale, right? When you've doubled the distance between everything in the cube and you've doubled all the lengths inside the cube, you haven't changed the angular momentum of anything in that cube. You haven't imparted any angular momentum on any of those processes. So the actual expansion of space and time itself within the Big Bang context is not responsible for imparting angular momentums on any of the celestial bodies. What you're talking about is more so with the formation of solar systems. So this would be like within the solar nebular hypothesis.
Right, so stellar. Yeah, so the stellar.
Yeah, so okay. In that case, like you would have, right, these like molecular clouds of like ice and dust, like kind of being pulled together by gravity into these spinning disks. And that's when you can talk about like the conservation of angular momentum in the formation of the planets and the stars. So within that context, there are a couple explanations that I've come across for Uranus and like the other like Venus, like these other bodies, some of the moons that are spinning the other way. So there's a few explanations. The first one is collisions with other objects, right? Like as they're all forming. If you have two objects that are both rotating around the disk in the same direction, right? If it passes within the orbit on the right side or the left side of a body, it's going to be captured by the gravity, either going one way or the other way. If it hits that, if the two bodies collide with each other, that's going to change the relationships of their angular momentums, and that can also reverse the spin. It can knock things off of their axis of spin, like with Uranus. So collisions will affect these things. And then the other big effect is with tidal torque. So that's whenever you have this relationship between, like for like Venus, for instance, with the sun and the other like Earth and the other planetary bodies nearby. Those actually exert a gravitational effect on Venus, which can slow down and like even reverse the spin of the planet based on like the tidal torque. So there's physical, naturalistic means by which these angular momentums of these planetary objects can be altered by, collisions and gravity.
Okay, so hold on there because you gave an explanation, but again, observe, study, test, demonstrate. We're stuck at observe. We have not observed any of this. We have not seen a new moon creation. So again, you're just trying to come up with an answer based on what your brain can think of. However, you didn't observe it, so you can't call this science. This goes back into the religion category. Now you
I'll
said
agree
collision.
that these are, sorry to cut you off. I'll agree that these are hypotheses, right? Like these are
right.
like
So
physically plausible explanations, but I agree that they haven't been observed. They're still in the hypothesis stage.
Right, and they will always be in the hypothesis stage. So guess what that makes them? A paradox. You'll never be able to answer the question. So collision of moons. Now, here's one thing that I find a problem with collisions of the moons. All right. Now, if there's a collision, let's say that, I have, this ball in this hand and this ball in this hand, and I throw them into the rotation of the moon, right? And then the Earth somehow throws it off, and these two balls collide with each other. There's going to be some kind of visible damage to both of these balls, especially with the rotation of these speeds. However, we don't see a moon with a piece chipping off of it. Okay, they're all perfectly rotated. We don't see fracture points, just like you would see a meteor come down to Earth and smash into the ground. There's a huge crater to answer that question, but you don't see that with these moons. So again, that kind of is a major road bump in your hypothesis as far as the collision of the moons.
Can I address that real quick?
Yeah, go ahead.
So, like the Theia collision hypothesis is a fairly consensus view on the formation of Earth's moon, and so that was when a large like Mars-sized body that we call Theia collided with the primordial Earth, and like the result of this collision was our moon. But the collision, you're right, was so so impactful that it actually liquefied the rock of both of these bodies. So you have this hot molten rock that then recondenses into two spheres by gravity.
So I mean that's a good chapter in your Bible, I guess. But again, this sounds like something that George Lucas just came up with, and then scientists were like, "Yeah, we'll adopt that idea." Again, it's a fairy tale. You can't prove it. Until you can prove something like that, you can't call it science. And that's the problem that creationists have with evolution, is that there's a lot of explanations that you guys come up with, but they're not backed by facts and observations. Okay. Now, as far as creation, we don't come up with the theory and we don't publish it because, especially not in your journals, because you won't let us publish in your journals. But we don't publish it in our journals until it has sound, observable evidence to back it up. Again, with the Bible as the foundation, we take the Bible, we say, hey, this is what it says. How does this fit with science? And then we go, we test it. And when we come up with a good answer that follows the steps of scientific method, then we post that in our publications, because we had to make our own because of the evolution communist system of peer review. Now, you guys will just publish any wild theory that comes out with no kind of observable data. And that's the problem we have, is you're telling kids this is a fact, But then when we have these conversations, you say, oh, yeah, that's just a hypothesis. But to a lazy 6th grader or to a lazy 8th grader that doesn't really care, they're just going to accept it as a fact. They're not going to question you on that. And that's the problem we have.
Okay, so in the interest of time, I want to keep going through the slides, but I will just say, like, these hypotheses, you're right, there are hypotheses, but they are based on known physics. Like, I think just this last year, we constructed the most like computationally sophisticated model yet, based on like real observable physics, like math that we know of, about what would happen when the collision of these two kinds of bodies of objects. And they show like the kinds of dynamics that would be at play based on the kinds of physics that we know about today. So it's not like they're just completely made up stories. Like, they are based on math and physics. But yeah, we can go ahead and move on, because we're still on point one of the
I
first
know.
point.
Yeah, we're going to be here for a while, man. So, I hope you had dinner beforehand. All right, so we'll go ahead and move on, but these are just the points that I'm making. So I want you to, I know that I'm not going to be able to convince you because you're diehard in your belief, just as I'm diehard in my belief. But I want you to understand why creationists have a problem with your theory. All right, because I think if we can understand each other on that point, then maybe you won't be so avid in trying to dismiss everything we say. Maybe you'll start considering things we have to say. But neither here nor there. Let me
I really
turn
think
off
it's
my.
a trust issue.
But what trust issue? Who are you having the trust problem with? Because my trust issue is with all of the people that have made theories and then they get proven wrong over and over again.
Yeah, I
But
just
as
don't
far
think
as
that
on my end,
creationists trust
I'm
the scientific community, or, I don't think that
accurate.
there's a trust that the work that they're going on is not, there's some kind of level of conspiracy or coincidence going on. There's not. Oh, there you go.
Yeah, it's accurate. I'll give you a thumbs up for that. That's accurate. We don't trust you guys because
Yeah.
we've caught you lying multiple times. The thing is, why don't you trust us? That's the question. Is it because you just don't want to accept God, or is it because you've seen us lie over and over again?
I mean, I don't trust the things that I don't see demonstrated, like with actual observational like evidence. So if I
But you
see
trust that the
observational
moon's
evidence
colliding.
to believe
You,
something, then
yeah,
I'll trust it if it's been substantiated. But
you said you don't trust things that aren't observed, but you never observed the planets colliding into each other to make different rotations. But neither here nor there. I'm just saying.
we
You're
do observe
saying
accretion disks.
okay. All right. So just in the sake of time, let's go ahead and move on. Okay. So here we go. I'll skip that. That's for my video. So yeah, now we're over to the laws of thermodynamics. Just going to go over the first law because that's the most obvious one. Energy cannot be created or destroyed. It can only be changed from one form to another. Now, I know that most evolutionists, they say, well, this is within a closed system. So I can understand that. But according to the Bible, the universe itself is within a closed system, because what the Bible says is that beyond the stars, there's another firmament. So according to the evolution model, the entire universe is a closed system of its own. Again, we can't prove that. It's just a theory or a hypothesis, as you want to call it. But according to our model, it's a closed system. So yes, the first law of thermodynamics should count for the entire universe, not just, within Earth itself. But here's what they have to say in your Bibles. Nothing really means nothing. From this state of nothingness, the universe began in a gigantic explosion. Oh, look at that. Explosion, not expansion. This theory of the origin of the universe is called the Big Bang. So there we go. Explosion tied to the Big Bang theory. This was in 89, so almost 40, 30, 33, 32, 31 years ago, something like that. But yeah, so then how does nothing exploding into all the energy in the universe and not violate the first law of thermodynamics? Because again, matter cannot be created or destroyed. So how does nothing create everything? Now, again, it says nothing really means nothing. So I know that y'all changed the theory since 1989, and you say that all of the matter and all of the energy was in this little infinitesimal dot. So I'll give you that. I need to update my presentation as far as that goes. But the real question I have is, how did you fit all of everything in the universe into a little bitty dot? How did that happen? And then where did that dot come from? That's the biggest question is, where did it all come from and how was it all condensed into a dot? Because we can't do that with anything today. There's laws that have to, there's laws of science that say that these things cannot be condensed down beyond a certain point. So how do you explain all the ocean being condensed down into a dot smaller than the tip of a pin?
Okay, so we've got a big chunk of conversation topics here. So first, I would ask you to go back to that textbook from 1989. I think that if you continue reading on that page, you'll see what I'm about to say, basically. The last two sentences are: the Big Bang Theory does not explain how the universe began. The theory only explains how the existing universe could have developed. So the science on that aspect actually has not changed since 1989. The Big Bang Theory still does not offer an explanation for how the universe began, where this energy, you say matter, but it's really energy that we're talking about at that point, like E equals mc squared, like there's an equivalence there.
Right, but I mean, energy is matter. So
Yes,
again,
it's
it's
just that
going to
it's at
take up
such
something.
high energies that actual matter, like atoms, could not have formed. The energy level would have been too high and too energy dense for any matter to be formed at that point. So, but that is the answer to your question about where did it come from? Where did this initial energy come from? Was it just created out of nothing? The Big Bang does not make any claims in that regard. There, below like a certain time frame of like 10 to the minus 33 seconds or something, like the first like Planck time, the Big Bang has no math to describe it. It makes no claims about it. It doesn't describe it at all. It doesn't say
Okay,
where any of this initially came
hold
from.
on. So
It
you
is
said the Big
currently
Bang doesn't
unknown.
say where it began, right? You say the Big Bang doesn't answer where the universe came from, right? But in this, okay, so here's what I'm saying: they have sentences within the same paragraph that contradict each other, because it says right here, however, physicists theorize that from this state of nothingness, the universe began. So, yes, they're trying to use the Big Bang to answer where everything came from and where the universe began. But then two sentences later, oh, but this isn't how it began. But that's literally what they said. They said the physicists theorized that from this state of nothingness, the universe, underline, began in a gigantic explosion. This is called the Big Bang. And then in the very next sentence, the Big Bang Theory doesn't explain how the universe began. So you have two contradicting sentences and that completely conflict each other. And this is what I'm saying. Over and over again, we can find these contradictions within evolution. You won't find those contradictions in the Bible, but you'll
Yeah,
find them
well,
all over the science books.
again, I don't really know about this textbook. I've never encountered this textbook. It looks like a high school textbook, but yeah, it does seem to contradict itself. I would not say that their first claim about the universe coming from nothing is substantiated within the Big Bang, or what we're really talking about is called the lambda CDM model. That's the more modern like version of this, like that encompasses all of our known cosmological science, is the lambda CDM model. But the Big Bang, like I said, even with inflation, it doesn't go back to T equals zero. It doesn't say where all this energy also ultimately originated from. So the only answer that I can, intellectually in an honest way convey is that it's unknown. And then
Mm-hmm.
for your second point here about just saying, how do we get this stuff condensed into such a tiny point? How is that possible? This actually ties in with your earlier question about what they're doing right now at CERN and particle accelerators, because they are actually concentrating this amount of energy into those tiny, tiny sizes. And they are kind of modeling some of this early universe physics before you had, back when, like what they're modeling is where you have such high energy densities that you can't have any atoms form. You can't even have protons form. Like this is so high energy that all you have is something called quark gluon plasma, which
Mm-hmm.
is sort of the earliest physically described thing that we can actually like observe and test at the moment in 2023 in the lab. And so we know what kind of dynamics are at play when you have energy that's been compacted that small. But what I will say is that at a certain point, right, you get to such high energies that not even, that you can't even have particles of matter being formed. And so particles of matter are called fermions, and then particles of energy are called bosons. So by E equals mc squared, there's an equivalence between the two. When you get to a certain high enough energy density, you're going to only have boson energy particles. And the key thing is that matter obeys Pauli's exclusion principle, and bosons do not, which means that a boson can occupy the exact same space as another boson, right on top of each other. They don't like two particles of atoms, two electrons or whatever. They cannot occupy the same space. Like matter, we all know intuitively can't just pass through itself. But a photon or like another kind of boson energy particle can occupy the same space, and you can stack, an infinite amount of it right on top of itself, and that is allowed within the currently understood laws of physics. So that's how we're able to condense things so far down, because once you have a certain amount of high energy density, all you're going to have are bosonic energy particles. You're not going to have regular matter.
So I'm not going to pretend that I know everything that's going on at CERN, but I do follow CERN and I do keep up with some of their stuff. I have to, watch videos to kind of simplify it. But regardless of that, there's a couple things that I want to point out about CERN. One, that is a highly controlled environment. All right. It is extremely controlled environment. And if even one thing goes wrong in that controlled environment, it creates an explosion, not a rapid expansion, an explosion, a very large explosion. And actually, they're saying that if anything were to ever go wrong, it could destroy our universe as we know it. So again, this is a highly controlled environment with severe consequences if things go wrong. Now, when we look at it from that perspective, how did this highly controlled environment happen in a pre-universe, right? So you can stack all these boson particles on top of each other. Although I would have to look into that a little bit more because I'm not fully convinced by that. So I would have to look into that a little bit more. But again, at some point, if that's not controlled, it causes massive damage to the universe. And if there's no universe, then it would probably prevent the universe from happening in the first place. Now, from those experiments that they're doing at CERN, remember, it's all very controlled. And if it goes wrong, it causes nothing but chaos. How do we get so much order out of all of that chaos? Because again, this is all controlled. And if you just let it go wild, it will create chaos. It won't create order. It won't create laws. It won't create organisms. It won't create beneficial mutation. It won't do anything beneficial left alone. So you see what I'm saying? Like, it's a very controlled environment. And this is the same thing with if we ever get to abiogenesis, the claim that, chaos is not going to create order. All right. Molecules have no desire to create life or structure. Molecules are very happy in their own state, doing their own thing. You don't see molecules actively trying to create life or actively trying to create organisms or anything else. They're on their own, doing their own thing. So we see plenty of problems with this.
Okay, so we're getting to a lot of points here. So I think your first point was on sorry, can you remind me what your first point was? I think we got to like 3 different points. You got to
okay. So
and
CERN is a controlled environment.
Yes, that's it. So, the controlled environment. So you would have this kind of increase in energy density, right? Like the reason why it has to be controlled and it's so complicated at CERN is because you're it's humans doing this in a very small experimental space where it's got to be recorded and it's got to be reliable, repeatable. But if like you have this case, right, where if you're kind of running the clock back, where right now our universe is expanding, so in the past it would be contracting, you're going to have less space. Now, because of the conservation of energy, you're going to have the same amount of energy, but now it's in less space, which means the energy density of the universe is increasing. So as you get less and less and less space, the energy density is going to go up and up and up and up. And eventually there's going to be so much energy crammed into such a small amount of space that it's too high energy for matter to even be formed. So it doesn't have to be this highly controlled kind of environment. All you need is less space, because that's just going to condense everything to and the energy levels are just going to go through the roof. And then for your second point, sorry, can you remind me what that?
Order out of chaos.
The what?
The order out of chaos.
Yes, order out of chaos, right. So you are correct in that in a closed system, the entropy always increases. That's a second law of thermodynamics. So in the very early universe, that would be the lowest state, like the lowest entropy state in the universe's history. So the very early stages of the universe had the most degree of order, and the amount of disorder and chaos, right, the entropy in like a scientific term, has only gone up since then. So right now, our state of chaos and disorder, I'm using those colloquial descriptors for entropy. The entropy now is higher than it was in the past. So the second law is intact there. And we can talk about the second law in terms of evolution and abiogenesis as well, but I don't know if we want to get all into that at the moment.
Yeah, we're going to move into that in a little bit here. But one thing I wanted to point out, though, is, again, the creation model, according to the Bible, says that the entire universe is in a closed system because there's a firmament on the outside. Now, we can't prove that because we haven't reached the end of the universe. But you can't prove that it's an open system because even if it is an open system, you'll never reach the end of it. Correct? Like if it's an open system, there is no ending to it.
Well,
so
whether or not it's open or closed, the universe is not a three-dimensional object that has like ends or edges.
Correct.
It doesn't really
what
work
I'm saying, the reason I bring that up, though, is because what I'm saying is this is where we stop. This is where we stop and draw the line in the sand from science to religion, because you're going to base all of your theories on your religious view of the universe coming from this dot and exploding and everything else. I'm basing mine off of it's created by God, and God says it's a closed system. And now, again, this is a paradox. We'll never be able to answer the question because I don't think we'll ever make it to the end of the universe. But that's what I'm saying. We're basing our foundations on, well, I'm basing my foundation on the Bible. You're basing your foundation on what men have come up with over the 6,000 years we've been here. And that's where I'm saying is like, this is where the problem is with creation versus evolution, is that I don't think y'all understand that no matter how much science you come up with, and no matter how many, well, I won't say science, no matter how many answers you come up with to these questions, until we have a solid foundation proven, that it's all just religion, because you can't prove a lot of the things that you're saying. And I think we haven't even made it out of the Big Bang yet. And multiple times you're saying, oh, that's a hypothesis. Oh, that's a theory. Oh, we think this like 10 times already that you've said that. So I think the viewers can see that even you are admitting that it's not a fact. And if it's not a fact, then it's not science. We're in the faith-based playground right now.
Well, theories and hypotheses are still part of science. Notice the first step in the scientific method is hypothesis. So this is part of the scientific method, right? We come up with theories that make testable, novel predictions that are falsifiable. And then we try to falsify them. And that's how we determine like the robustness of a theory. So some of these, like the Big Bang theory, is quite robust. The lambda CDM model is a very robust theory that describes a whole lot and has a whole lot of verified, testable predictions. And then others, like I know you said we're still in the Big Bang, but we were on solar system formation for a while there. That's a totally different realm than the Big Bang. That's the solar nebular hypothesis, which it does not have the robustness of the Big Bang model and still has a lot of things that are unknown about it. The difference, I guess, is what I'm saying is like, I'm okay to have unknowns, right? It's okay. Like if we don't have enough evidence to say something for certainty, then I'm not going to. It's okay to me to not know something.
Right. And again, I have no problem with us not having all the answers. But the problem is that you're taking not having all the answers and then putting your interpretation on it. That's where the problem comes in. So I guess let's go ahead and continue on so that hopefully we can get somewhere, because we have not gotten far at all. Like this is barely the beginning of the presentation.